Welcome to this tutorial and showcase of my iRacing telemetry analysis software. If you would like to download my software, it can be found through a download link in the video description or found on my GitHub. When launching the software, we are met with a file browser or drag and dropper where we can place the CSV of our telemetry. It's important to note that by default, iRacing saves all telemetry data as an IBT file. For a full tutorial on how to convert IBT file into CSV file format, be sure to check my previous video, which I will also link in the video description. Now let's drop the CSV of our telemetry data into the software. Upon placing the CSV of our recorded telemetry data into the software, we now need to select what type of session the recorded data is from. In this case, it was a practice session. We can now press continue and load the data into the software. Note that depending on the length of the recorded session, loading the telemetry into the software can take anywhere from a few seconds to a few minutes, as iRacing's telemetry data can be fairly bulky in size. When the telemetry has been fully loaded into the software, we are first met with the session overview screen. Note that this screen will change depending on what session type we selected at the previous step. Let's take a quick look at the qualifying overview screen and the race overview screen. Due to iRacing's qualifying sessions typically being limited to 2 laps, the qualifying overview screen simply relays to you information regarding your fastest lap, such as what lap was set on, as well as the sector time breakdown. On the race overview screen, you can see a table which lists your starting position, your finishing position, your net positions lost or gained, and the length of the race in laps and time. Beneath this, we can see a table that features lap-by-lap position changes. These tables are accompanied with a track map. Beneath this, we can also see a line chart, which plots your performance throughout the race. Let's move back to the practice session overview screen. Before we get into detail on this screen, let's take a look at the top of the software, where we can see the driver name, the vehicle they were driving, and the track at which the session was recorded. In this case, I was driving the Formula 4 car around the Barcelona GP layout. In the practice session overview screen, we can see the number of laps completed, the fastest lap, and on which lap this was recorded. We can also see a track map. Above the track map and the table, we can see a banner displaying some of the environmental variables from the recorded session, such as the weather, the air temperature, the track temperature, the humidity, the air pressure, and the air density. Now let's move on to the timing data screen. The timing data screen provides summarization data of our recorded lap times, as well as individual lap breakdowns and visualizations. At the top of our timing data screen, we can see a banner featuring some summarization data, such as our fastest lap, the average lap time, the median lap, the standard deviation of our lap times, and the number of valid laps. We can also see a consistency score that is awarded to players. The score that is awarded to drivers is related to a matrix that is calculated using the valid laps percentage as well as the standard deviation of our lap times. In this case, a valid lap is a lap in which the player did not leave the track and accrue a penalty. Essentially, the consistency score rewards drivers for setting consistent lap times and remaining on track. Beneath this banner, we can see a table which provides a full insight into each lap time as well as our sector times and the delta to the fastest lap. There's also some color coding featured on this table, where yellow indicates an in lap, blue indicates an out lap, and green indicates the fastest lap set. It's also important to note that in-laps and out-laps are not taken into consideration when calculating any of the summarization data in the banner above and the consistency score. The table is fully interactable. Users can select any header to sort the data as they wish. For example, let's sort lap times by fastest to slowest. Users can also select any lap in the table to update the track map to visualize the delta between the selected lap and the fastest lap. For example, let's take a look at lap 12. Now that we've selected lap 12, it has updated the track map, and we can see where we were faster and slower compared to the fastest lap. Here we can see that out of turn 1 and all the way coming into turn 4, we were faster than the fastest lap, as well as during the middle section of the track. The track map can also be switched from a delta view to a speed view. The speed view displays a heat map of our speed throughout any selected lap. This can also be switched from kilometers an hour into miles per hour. Beneath the track map and the table, we can see a line chart. This line chart plots our lap times throughout the session. Note that in-laps and out-laps are denoted using these yellow squares, and the fastest lap is denoted using this green circle. The line connecting laps on this line chart will be green or red, depending on whether the lap was faster or slower than the previous lap. This is important as sometimes the difference between lap times can be marginal. Let's move on to the pedal usage data screen now. The pedal usage data screen provides you with a full insight into your throttle and brake usage throughout the recorded session. First, let's take a look at the lap selector on the left. By default, this will be listed in chronological order, but can be switched from fastest to slowest to fastest in terms of lap times. The track map is displayed using 3 different colors, where green indicates throttle usage, red indicates brake usage, and yellow indicates coasting. In this case, the driver is considered coasting when both the throttle pedal and the brake pedal are at less than 3% input. Beneath the track map, we can see a play button. Pressing play will begin a replay of the selected lap in the lap selector. It will also initialize both rolling line charts on the right of the track map, one for pedal input and one for gear. As we come into the braking zone, we can expect the throttle to fall off and the brake to be applied. Users can also speed up this playback. Let's speed it up a bit to get to turn 4. By pausing the playback after a braking zone and corner, it will also stop the rolling line charts, allowing us to analyze our brake and throttle usage entering and exiting the corner. The playback also features a speedometer, which is selectable in kilometers an hour and miles per hour. Above the track map, users can switch from throttle and brake visualization to look at gear usage. The gear usage track map allows us to look at where we are making gear changes on any selected lap, as well as what gear we are in. Note that the thin blue line between gear changes indicates us being in neutral temporarily when upshifting and downshifting. Both the gear track map and the pedal track map are fully explorable, where users can zoom into specific sections of the track to analyze their performance, as well as zoom out to gain an overview. Let's move on to the lockup data screen. The lockup data screen allows us to see when and where we experienced a lockup during the session. On the left, we can see a lap selector. Laps in which a lockup was detected will be accompanied with the warning symbol. Let's take a look at just lap 4. As you can see, lap 4 wasn't that great, with 3 separate locations in which lockups were detected. The table on the right-hand side of the track map allows us to look deeper into what was actually going on during these lockups. Users can double-click any lockup on the track map and the associated lockup will highlight itself in the table. This also works both ways, allowing users to click any lockup in the table and the associated lockup in the track map will become highlighted. Let's take a look at the first lockup. As we can see, this lockup occurred on lap 4, and it was the front right tyre that locked up. The max temperature on the surface of the tyre that was recorded during this lockup was 110 degrees, and the brake usage at the time of lockup was 96%. The duration of this lockup was 0.22 seconds. Let's reselect all the laps in which a lockup was detected. Above the lap selector, we can also filter for which tyre is locked up. For example, let's look at just the front left lockups. By filtering for only the front left tyre, we can see that we locked up on turn 5 of lap 7 and we locked up on turn 11 on lap 4. The banner beneath the lap selector and the track map provides overall statistics on our lockups. It's important to note that this banner is relative to what laps are selected. When filtering for all laps, we can see that we experienced 7 lockups in total, with an average of 0.4 per lap, 2 lockups on the front left and 5 on the front right. Let's move on to the tyre data screen. At first glance, the tyre data screen may appear a little intimidating, but what's going on here is very interesting and extremely useful. Once again, on the left-hand side of this screen, we have another lap selector. The center graphic provides a top-down view with each of our tire surface temperatures, with each tire being split up into 3 separate sections: the outer surface, the middle surface, and the inner surface. This graphic is dynamic and will update in tandem with the playback feature on the track map. But before we move into the playback feature of the track map, we can also see a line chart down the bottom right of the tire data screen. This line chart features 4 distinct lines, one for each tire. The green section on the line chart indicates an optimal tire temperature range. The vertical black line on the line chart is a sweeper line that also will play in tandem with the playback feature. Let's begin the playback feature now. Keep a close eye out for our front left temperatures as we take the fast and sweeping T3. Also featured on the tire data screen is a scatter plot and correlation chart. Here we can see the correlation between our lap times and our tire temperatures. While I'm on the tire data screen, let's go back and check where exactly I locked up so we can see if those temperatures are reflected on this screen. Here we can see that the highest recorded temperature during a lockup was our right front tire on T4 of lap 4. So if we go back to the tire data screen and go to lap 4, we can see the moment at which I locked up. Let's watch it in the playback. Let's now move on to the final screen, the fuel usage data. The fuel data screen provides us with an overview of our fuel load and consumption throughout the session. At the top of the fuel usage data screen, we can see a banner featuring general information related to our fuel loads and consumption, such as our initial fuel load, the total fuel use in the session, average usage per lap, and on which lap we use the most and the least amount of fuel. It's important to note that fuel is not only measured in litres but also in kilograms, as this is a crucial piece of information when it comes to optimizing lap times or planning out the optimal pit strategy. Beneath the banner, we can see the track map, which portrays to us where we were using and saving fuels on any selected lap. In the track map, heavy fuel usage is indicated as red and light fuel usage is indicated as green. Any lap can be viewed in the track map window by selecting the associated lap in the bar chart located to the right of the track map. For example, let's take a look at lap 15's fuel usage. It's important to note that laps in which refueling occurred are excluded from the bar chart. In this case, it was lap 9. Beneath the track map and lap chart, we can also see a scatter plot, which plots our lap time in association with our fuel load, as well as a correlation line. As expected, we can see that as my fuel load decreased, my lap times improved. In-laps and out-laps are not featured on this scatter chart. Lastly, we can switch from the fuel usage bar chart to a fuel level line chart, which measures our load throughout the session. This line chart provides a great opportunity to plan out the perfect pit strategy if you're competing in an endurance-style event. The last thing featured in the version 1.0 release of my software is a data previewer. This page isn't crucial, but I decided to include it for those of you who want to take a look at what iRacing's raw telemetry data looks like. Thank you very much for watching. I hope my software can allow you to improve and become more consistent as a sim racer. If you have any questions about the software, please feel free to comment them down below or contact me privately through the Gmail listed on my GitHub. I'll now leave you with a replay of one of the laps set in this session, accompanied by some telemetry from my software. Thanks again for watching. Take care.